Good morning to all. Myself Professor Archana. We are continuing on course Fundamental of a Carbon Capture, Utilization and Storage. So in the today's discussion, I am going to talk about CO2 flooding concept. So lastly, we have started this topic, that is CO2 EOR. So first we get the concept of the CO2 utilization. So we get the idea of CO2 utilization. So one utilization of CO2 is about in the CO2 EOR project. So what we do here, CO2 will get it injected into the subsurface and it improves the oil recovery. So we require to understand that. So let's start with this one. So what is this CO2 flooding concept? And it does need in for your enhanced oil recovery. So in an oil reservoir, only a portion of original oil in place can be recovered using the conventional method. So let's understand the different oil production stages. So this oil production generally occurs in three stages. So the first one, we do have the primary recovery. So this primary recovery uses the natural energy of the reservoir, that is your natural pressure, then dissolved gas expansion or water drive. So this natural energy of the reservoir is being utilized to recover the oil, and that we call the primary recovery. So in the primary recovery, the question arises how much oil can be produced. So 5 to 15% of original oil in place can typically be recovered during this stage. So that means during the primary recovery. Then the second recovery, we do have the secondary recovery. So when reservoir pressure declines over a period of time, the first we do have the natural pressures. So as this oil keep extracting from the subsurface, there is a declining in the pressure. When reservoir pressure declines, secondary recovery method are applied. So what are the different secondary recovery methods? So the most common technique is water flooding. So using this water flooding, what we do? We increase the pressure which is reduced during the primary recovery phase. So this most common technique is nothing but the water flooding, where water is injected into the reservoir to push oil towards the production well. And water flooding gives you the pressure maintenance as well. So this secondary recovery can increase total oil recovery to about 30 to 40% of the original oil in place. However, even after secondary recovery, what is happening? A large amount of oil remains trapped in reservoir pores. So why it is being trapped in reservoir pores? It is due to maybe this oil is having the high viscosity. So high viscosity oil cannot make movement. So for that, we need to reduce the viscosity. Then the capillary forces. Maybe this capillary breakage is too high, so oil is not able to come out of that one. Then this capillary forces is something to do with the wettability. Then the first point is the high oil viscosity. Then the third, we do have the poor mobility of oil. So these three problems, which is the reason for large amount of oil is still being trapped in the reservoir pores, we require to break this. We require to reduce the viscosity, we have to break the capillary forces, and we have to give the mobility of the oil. So to recover this remaining oil which is still trapped, and that is into the large amount, because only 30 to 40% of the original oil in place was recovered in your primary and secondary recovery. So still approximately 60% of oil is still trapped, and that required to recover. So to recover this remaining oil, this tertiary recovery method, or we call the enhanced recovery oil method, is used. So under that enhanced oil recovery method, we do have the CO2 flooding. Here comes the CO2 flooding. So CO2 flooding you can consider one of the EOR method, or enhanced oil recovery method. So CO2 flooding is a type of a gas injection, okay, which we call enhanced oil recovery method, in which carbon dioxide is injected into an oil reservoir to increase the oil production. So what is this whole process? So carbon dioxide is injected into the reservoir through, there would be injection well. Injection of a carbon dioxide into the subsurface through the injection well. That's the first thing. Second step, CO2 is interacting with crude oil present in the reservoir or rock pores. Then third, interaction between CO2 and oil will improve the oil mobility. So what was the problem? There is a poor mobility of oil. So the solution is to improve the mobility. So improving the mobility by some means. So here the means is what? CO2. So CO2 is interacting. So the interaction between your CO2 and oil is improving the oil mobility. So once this oil mobility will improve, what will happen? Oil is displaced towards the production well. As a result, what will happen? Additional oil that was previously trapped in the reservoir will be produced now. So what is the basic principle of a CO2 flooding here? We get it? The main principle behind CO2 flooding is that carbon dioxide can mix with your crude oil and alter its physical properties. So here what was happening? There oil is displaced towards the production well. Before that there is interaction between injected CO2 and oil, and that interaction is improving the oil mobility. So the basic principle tells us CO2 can mix with crude oil and it can alter its physical property. So CO2 is capable of altering the physical property of oil. So when CO2 enters in the reservoir, CO2 dissolve in crude oil, so oil viscosity decreases, oil volume increases, or interfacial tension decreases. And these four phenomena is assisting in producing the more oil. So these changes allow the oil to flow more easily through the porous rock towards your production field. So let's understand this behavior of a CO2 in reservoir condition. So under reservoir condition of high pressure and temperature. So high pressure, high temperature we are getting in the reservoir. At this high pressure and temperature, CO2 often exists as a supercritical CO2. So supercritical CO2 has properties of what? Supercritical CO2 has properties of your oil and gas both. So what the characteristic here we do have? When we have CO2 in the supercritical phase or supercritical CO2. So gas like ability to flow easily through the rock pores. That's the first ability. The second, liquid like density that improves contact with the oil. That's the second thing. Then high diffusivity, allowing it to penetrate oil effectively. So that's the three things we do have. Gas like ability to flow easily, and then liquid like density that improves the contact with the oil. Then high diffusivity will allow CO2 to penetrate oil effectively. So that's a very important one here. So this supercritical CO2 is having these three characteristics, and these properties make CO2 particularly effective for enhanced oil recovery. So we have get it how this CO2 behavior in reservoir conditions. So we do need CO2 in the supercritical form, and once it is in supercritical, we have this characteristic. Now let's talk about some injection processes. So CO2 injection process, here first we will understand, and then different injection process which we do have it, pattern, not process, pattern we will focus on. So CO2 flooding process involves several steps. So the first one we do have the CO2 compression. So this captured CO2 is compressed to high pressure, so it can be transported and injected into the reservoir. So the first thing we do have capture the CO2. After capturing, what we do? We compress it. So that's the first step. The second step, injection into reservoir. CO2 is injected into the reservoir through your injection. This injected CO2 is spread through the porous rock formation. Then when we are talking about the CO2 EOR, that means we wanted to extract the remaining oil. So there is a presence of a oil. and we have injected the CO2. So the next we do have interaction with the oil. So as CO2 moves through the reservoir, it interacts with crude oil, and what it does? Viscosity reduction, oil filling, and extraction of a light hydrocarbon from your oil. So there would be extraction of a light hydrocarbon from the oil. Then fourth step we do have oil displacement. So the mobilized oil is pushed through the reservoir towards your production well, where it is brought to the surface. And then fifth step we do have CO2 recycling. So this produced fluid often contain both your oil and CO2. So at the surface, once we do have oil and CO2, and we want to recycle this CO2. So we do have at the surface, CO2 is separated from the oil. That's the first thing. CO2 is recompressed because again we require to re-inject it. So this now pressure reduced, so we require to again compress it. So CO2 is recompressed and then CO2 is re-injected into the reservoir. So this recycling process will improve the efficiency and reduces the CO2 consumption. So this is the CO2 injection process we do have it here. So from compressing to again CO2 recycling. So this is the difference. So let's understand this pattern of a CO2 flooding. So in many reservoirs, injection and production well are arranged in flooding pattern, and reason is to maximize the oil recovery. So some common pattern I will be discussing it here. So the first one is the 5 spot pattern, then we do have the line drive pattern, then we are talking about the 7 spot pattern. So this pattern ensure that injected CO2 sweeps large portion of the reservoir. So as it sweeps the large portion of the reservoir, it does contact the larger portion, and then there will be more interaction between your injected CO2 and oil. So the first one is the 5 spot pattern. It's a common well arrangement used in CO2 flooding for your EOR to improve the oil extraction from the reservoir. So what is the structure here of 5 spot pattern? The pattern consists of 5 well arranged like in number 5 on a dice. So here how it is: one injection well that is placed in the center. So you can take this as an injection well, and 4 production well we do have. So this is the 4 production well. So this the we can represent by the different notation. So this is the 4 production well, and at center we do have the injection well. So this is the injection well, and it is a surrounded by the 4 production well. So this is the arrangement we are talking about. So this layout form a square pattern across the oil reservoir. So how CO2 flooding works in this pattern? CO2 injected into the central injection well. So here there is an injection of the CO2 into the central injection well. So this CO2 is spread outward through the porous rock after the injection, and it mixes with oil, and what it does, it reduces the oil viscosity, and as the oil viscosity will get it reduced, it makes the oil flow easier. So this oil is pushed towards the 4 surrounding production well. Once it is getting spread, then there is a movement of the CO2 towards oil, and this way the produced oil is collected at the surface. So what is the advantage of using the 5 spot pattern? There is a uniform displacement of the oil from the reservoir, efficient sweep of the reservoir area, simple and widely used well layout pattern, and work well for regular swept reservoir. So this variation we can make it. Sometime the pattern is reverse. So that variation is also is done. So what the variation we are doing? Initially we have taken the 1 injection well and 4 production well. Now here what we are doing? 4 injection well at the corner. So now this is my 4 injection well at the corner, and at center I have the production well. So this is my production well, and at 4 corner I am talking about the injection well. So this is it. So this is called the inverted 5 spot pattern. So two things we do talk about. One is the regular injection, we are talking 5 spot pattern, and then there is a variation also, that is a inverted 5 spot pattern. So these two pattern we are applying in CO2 injection. Next we do have the 7-spot pattern. Is another well arrangement that is used in CO2 flooding for enhancing the oil production to increase the efficiency of the oil extraction from the underground reservoir. So what is the structure here of the 7-spot pattern? In this pattern, 7 wells are arranged in hexagonal layout. So one injection well in the center and 6 production wells placed around it forming the hexagon. So this is the one. So if I can take this the one well, this is another, this is another. So it is what hexagonal structure we are talking here. So one injection at the center. So this circle I am representing injection well, and this surrounding I am talking about the production well. So one injection well here at the center and 6 production, which is forming your hexagon. So the total number of well we can say 7. So how does it work in case of CO2 flooding? CO2 is injected through the central injection well. So through this one injection well it is injecting. This gas is spread outward through the porous reservoir rock, and CO2 mixes with oil and reduces its viscosity, and oil becomes easier to move and flow towards the 6 surrounding. The oil is then pumped to the surface. So what is the advantage of using the 7-spot pattern? Better reservoir coverage than some simpler pattern which previously we did talk. More uniform oil displacement will be there, and then the point can improve the sweep efficiency of your CO2 flooding, and it is useful in the large reservoir. So there is something like we can inverse also, that there is a inverted 7-spot pattern. So now in place of a 1 injection well, we do have the 6 injection well and 1 production well, that is at the center, and 6 injection well will be around the edges. So this is called the inverted 7-spot pattern. So broadly here I am just mentioning 5-spot pattern. So I can take it regular 5-spot. Okay, then I have here inverted 5-spot pattern. Then here, sorry, I can remove this one. This is the regular we can call 7-spot pattern, and this the one inverted 7-spot pattern which we are talking about. So this the two we have discussed. Now one more, that is a line drive pattern, is a well arrangement used in CO2 flooding, again for enhanced oil recovery, where wells are arranged in parallel rows across an oil reservoir. So what is the structure here? In this pattern, a line or a row of injection well is placed on one side of the reservoir, and a parallel row of production well is placed opposite side of the reservoir. So layout looks like 2 parallel lines of a well. So I can take this one, this, and this is the another one. So this 2 parallel line it looks like. So one line is completely for, we can take this triangle one injection well, and this we can take the production. Okay. So how this CO2 flooding works, this arrangement, CO2 is injected through the rows of injection well. So this row injection of CO2 was done. The gas moves horizontally through the reservoir rock. Okay, and CO2 mixes with oil and reduces its viscosity. This oil is pushed towards the production well located in the parallel row. So this is the one, it is pushed towards the your production well. Oil and some CO2 are produced at the surface. And what is the advantage of using this line drive pattern? Simple well arrangement, suitable for large and elongated reservoir. That's another important thing. Easy to expand across large oil field, and it provides a continuous sweep of the reservoir. And but there is some limitation, may cause uneven sweep efficiency if reservoir is irregular, and CO2 may break through early to production well if permeability varies. So that is the limitation here. So we get the idea of CO2 flooding pattern. So this 5 spot, under that too we do discuss 7 spot, and then we do discuss the line drive pattern. One more we do have it here, that is the water alternating gas injection. So currently we were talking about CO2 flooding using the different patterns. There is a one thing it was mentioned it here, apart from continuous flow of the CO2 some option more are there. So what the different option here, we are water alternating gas injection. So you are injecting water and then CO2 and then water. So that's we do have. In some CO2 flooding operation, CO2 injection is alternated with water injection. So this method we call that water alternating gas or WAG. So the what is the advantage of WAG? So it improves better sweep efficiency, it reduces the gas channeling and improve the contact between your oil and CO2. So this technique is helping to maximize the oil recovery while minimizing the CO2 uses. So that's the thing, because alternatively you are using the water. So that's the name suggested, water alternating gas. So this the about some idea of the flooding pattern. Now let's see CO2 flooding efficiency. So the success of a CO2 flooding, it depends on the several factors. So this reservoir pressure, reservoir temperature, oil composition, permeability of your reservoir rock, injection rate of a CO2. So these are the parameter on that CO2 flooding does depend, and the efficiency of the CO2 flooding also depends. So if reservoir conditions are favorable, CO2 flooding can be significantly increase your oil recovery. So in many reservoirs, CO2 flooding can increase oil recovery by an additional 10 to 20% of original oil in place. So in the next topic, we are going to discuss more detail about uh, different way of flooding. CO2 flooding can occur in two different modes. One is the miscible CO2 flooding and another one is the immiscible CO2 flooding, which I am going to talk about this mechanism in the coming class. So these two mechanisms determine how effectively CO2 displaces oil in the reservoir. So this next topic will be covered the type of a CO2 flooding in detail. So in the today's discussion, we have started this CO2 flooding. So it is an enhanced oil recovery technique, and that is used to extract additional oil from reservoirs that have already undergone your primary and secondary recovery. So the basic concept here we do have carbon dioxide is captured from industrial sources or natural reservoir. CO2 is compressed and injected into underground oil reservoir through injection well. CO2 mixes with oil and reduces its viscosity, and that way it is making oil more thinner and easier to flow. And then the injected CO2 also increases reservoir pressure and pushes the oil towards your production well. So this oil and some CO2 are produced at the surface. CO2 can be recycled and re-injected. So the main effect of CO2 in the reservoir is reduces the oil viscosity. That way oil flows more easily. Swell the oil and increasing its volume. Reduces interfacial tension between oil and rock and improves the mobility of the trapped oil. And then we do talk about some injection pattern. So pattern of a CO2 flooding refers to the arrangement of injection well and production well in an oil reservoir to ensure efficient distribution of injected CO2 and maximum oil recovery during your EOR process. So purpose is to ensure uniform sweep of the reservoir, push oil efficiently towards production well, improve oil recovery efficiency, and then we do discuss some common flooding pattern, 5 spot, and then we have in the 5 spot, so inverted and regular. So this first one injection in the center, then 4 production well at the corner. Then we do talk about reverse, where 4 injection at the corner and 1 production at the center. Then we had the 7 spot, where total 7 well we are talking. So 1 injection well in the center and 6 production well arranged in a hexagon around it. Then we have the inverted where 6 injection well arranged in hexagon and 1 production at the center. Then we do have the line drives pattern, row of injection wells facing parallel rows of production well, and it is suitable for large and elongated oil reservoir. So overall idea we do have different flooding pattern are chosen depending on your reservoir size, shape, permeability and oil distribution to achieve the best CO2 efficiency and maximize the oil recovery. So this is all we have discussed today, and then we will talk about this different CO2 flooding, CO2 miscible and immiscible CO2 flooding in the next class. This is all for today. See you in the next class.